I got it hooked up to what they call a function generator, which tells the speaker how fast to vibrate. And so I'm going to turn the power onto the function generator. And I'm going to make it vibrate a little bit faster than the spring was going at. Now, if this bothers your ears, I'm sorry. But not that much. Now notice, you can already hear a sound, right? It's not very loud, because it's not a speaker. But what you're hearing is you're actually hearing the metal itself. It's the metal that's singing. Okay? I already ripped the cone out of this thing. There's no cone in there. So the only thing that could possibly be making the sound is the metal itself. The metal is vibrating. But when you look at it up on the screen, there's not much to see there. Because, you know, it's black. Okay? So what we're going to do is I'm going to put on top of it sand. Now what do you think the sand's going to do when I drop the sand on top of it? It's going to bounce, right? It's going to like shake like crazy. So let's see what happens. Take my sand and put my sand on top. Right? And now I'm going to turn it up. And hopefully you can kind of see the sand starting to move. I'm just bound and determined to destroy that thing, Miss Classberry. You see that? See that pattern form? Well, all of the sand was bouncing right here, right? And so that was where the fat part was, the antinode, right? So this is kind of an antinode there. And then this spot here, where the sand is collecting, the plate's not actually doing any moving there. So since the plate's not bouncing the sand around, it all sits there. And so that's one way that you can kind of see the wavelength. So if I increase the frequency, what would you predict will happen between the distance between those rings? Right, they'll get close together. There'll be more rings. So let's try that. They bounce off uniformly and come back, and so you get a nice shape like that. But if I take it and I change the shape of the plate to something that's not a circle, then it gets a little bit more interesting. And so what I'm going to do is I'm going to take a square plate, and I'll mount the square plate on here. And so what this is going to do is, notice the wave is going to start in the center and it's going to radiate out in a circle. But what's going to happen is it's going to hit this edge, right? It's going to hit that edge first. And then it's going to slowly hit that side and that side and that side. So it's going to bounce off at different times, right? So instead of having a nice uniform circle, other stuff happens. So again, it's singing for us. Can't carry a tune. Sings as bad as I do. get a different pattern than I found when I had the uniform circular motion. Now I get like little flowers and stuff being drawn. And this one's kind of cool. And it makes a pretty good point. So let me tell you about this point. Okay? This is a fairly nice geometric shape, and if you were to like not have been in this class, right, and walk in here and like look at it, you'd be like, oh man, who drew that? Okay? Because it looks like somebody like went out and drew this nice uniform shape. And it turns out that we actually see these nice uniform shapes in places other than where people live. Like on Saturn, there's this a hexagon shape in the clouds on the pole of Saturn. And for a long time they're like, well, what could cause that? I mean, a nice regular shape like that, that's like, maybe there's an intelligent life form that's creating that shape. And it turns out that there's probably not. I mean, I've not personally been there, and we don't have any probes that have actually gone down. To my knowledge, we don't have any probes that have gone down in the atmosphere of Saturn. And so, I mean, we can't say for certain, but what we can say is what's probably happening is we're having these standing waves forming. And it just looks like we're having nice geometric patterns. Well, the patterns are geometric, but they're not being created by people or other intelligent creatures. And as I increase the frequency, then again, I get different patterns. And as the frequency gets higher and higher, then the pattern gets more and more complex. Because the distance between the little pieces gets smaller and smaller, so there's more room for the waves to get all crazy. So that's the short version. Now, let me show you a practical application for this, because I mean, as fun as this is, there's not much use in that. But 23. How much time do I have?
And you got about 3 minutes, which is short.
3 minutes. Good. So here is the shape of a violin body.
And I already told them about shapes of instruments.
Okay, so here we go.
So you got a little more time.
I'll spare you the explanation and just get to the fun. So the shape of a violin, or the shape of any acoustical instrument, is one in which, at the specific frequencies that we call musical notes, that it causes a resonant wave to form, a standing wave pattern. And so each time a pattern forms, that would be another musical note that you could play with your instrument. And then they make all kinds of different patterns. Alright. So let me show you one more thing. And if the bell rings, then you're more than welcome to go. But this is just for fun. This actually isn't... Certainly not.
This is the one I showed you real quick. This is the cornstarch and water. It's not like what he's doing, but where the guy could run across it.
This is the same material that they had. But instead, here we go. Will somebody hit the lights for me? Thank you, I appreciate it. Alright, so I'm going to, real quick, a fun little thing. This is what physics teachers do when we're bored and have nothing better to do. Now, you know that when the cornstarch, pressure, it makes it solidify a little more. And so if we use a speaker to go ahead and vibrate it, then we have different amounts of pressure at different areas. And so we have viscosity which keeps changing it. So if I put it at the right frequency, then a little cornstarch monster starts to appear.
Y'all saw how if you went into it slowly, some.
Have a good day. Have a nice weekend. If y'all want to come see it, you can.
You're getting a little too into it.
That's not enough fun.
Cody, you're like it bit me! I wonder if it would like form around your finger.
You guys done, right?
Oh, let's go back. Let's go back. It looked like a loogie.
Get off of me.
Is it cornstarch?
Yeah, it's just cornstarch water.
Okay. Oh
You can make it sound
That's like crazy. Cody, are you actually playing with it?
Yeah.
I have bad fingers.
It's like forming around my finger.
Cody, I have bad hands.
Dude, it'll form around your finger. Watch.
That is gross.
That's so weird.
I'm making a
Hey,
sandcastle.
old man, put your hand on it.
I have bad hands.
How am I an old
I
man?
have bad hands. That's so cool.
You have a nice weekend. Put your chairs in.
This was like the best way to start the weekend.
Who wants to help me make a sandcastle? Oh wow, like grips it. Yeah, get off.
Touch it, and it comes out.
Yeah.
Whenever you're gonna use that, tell me like a day ahead. 'Cause I have
Oh
the
right, I
big
gotta
one.
go.
Yeah.
I'll bring you that one.
Okay, cool.
Yeah, you
cool. I
can
want to see
cook
it.
it.
I had a big one like two certain ones, huge, like that in my room. I would have brought you that one.
Well,
Okay.
You can go wash my hands.
just use a sink like that. Oh. I got lots of sinks. I got more sinks than I got know what to do with.